Have you ever tried to get an AI to do just one too many things at once and it just completely breaks? Well, guess what? It turns out AI engineers are feeling that exact same frustration. These systems, the ones that are supposed to be so brilliant, are hitting a very real wall. So let's dive in and figure out how to get them unstuck. And the secret isn't a single super agent, it's a super team. It really all starts with this feeling from an LLM engineer, Timothy. He's just looking at his system totally fed up. He realized that whenever a user gives it a complex command, something like, hey, can you pull the data from this scanned invoice and update my inventory database? The whole agent just falls apart. It gets confused, it mixes up the tasks, and in the end, it just fails. So the heart of the issue is what we can call the overworked monolith. We're treating the AI like it's this single giant brain, and we're just trying to cram every possible skill and every possible tool into it. But just like a person, when you ask it to be a world-class expert in everything all at once, its focus gets shattered, its context window gets messy, and that is exactly where the mistakes and the hallucinations start to creep in. So what's the fix? Well, this is where Timothy's colleague, Margaret, comes in with this really paradigm-shifting idea. She says, instead of one overworked, do-it-all agent, what if we built a team of specialists? The whole idea is to stop building one single monolithic AI and start building a smart, modular team. And when you put these two architectures side by side, the difference is it's night and day, right? The old way, the monolith, is one agent trying to juggle everything. It has all the tools, and that just leads to total confusion. But with the multi-agent team, wow, each agent is a specialist. It only has the tools it needs for its one job. And the result? The context is crystal clear, and you see way fewer errors. Now, the secret sauce that makes this all possible is a concept called domain isolation. The best way to think about it is like putting blinders on a horse. You are intentionally limiting what the agent can see and do. You give it only the exact tools in the specific knowledge it needs for its one single job. And that intense focus, that becomes its superpower. So in the real world, this team might look something like this. You've got a data extraction agent. Its entire universe is just optical character recognition and text analysis. That's it. It literally doesn't even know the inventory database exists, so there's no way it can mess with it. And then you've got the inventory management agent. Its sole purpose in life is talking to database APIs. See? Each one stays completely in its own lane. Okay, I know what you're thinking. Timothy asked the exact same thing. If these agents are so isolated and so specialized, how do they coordinate? How does the team actually work together to solve one big request from a user? Who's calling the shots here? The answer is the orchestrator. This is the manager of the AI team. Think of it like the project lead. It sits one level above all the specialists and just directs the traffic, making sure everything gets done in the right order. And here's the really important part. The orchestrator doesn't do any of the heavy lifting itself. Its job is all about judgment, not labor. It's not using the OCR tools, it's not calling the database. No. Its job is to listen to what the user wants, break that big request down into small, manageable steps, and then it routes those steps to the correct specialist. It's the decider. Okay, so we've got our manager and we've got our team of specialists, but there's still one piece of the puzzle missing. How does the information actually get passed between them? I mean, if the extraction agent pulls some key info out of a file, how does the inventory agent get its hands on that info to do its job? And the metaphor they came up with for this is just perfect. It's a relay race. The entire workflow is designed like a handoff, where one agent finishes its part of the race and then passes the baton to the next agent in line. So let's walk through the play-by-play. First, the user makes their complex request. Second, the orchestrator steps in and breaks it all down. Third, and this is the critical move, the first specialist, our extraction agent, does its job and then saves its results to a shared location. Finally, the orchestrator tells the inventory agent, hey, go to that spot, pick up the results, and finish the job. That shared location we're talking about, it has a name. It's called the shared state. This is the baton in our relay race. It's a common memory space, kind of like a digital Dropbox, where one agent can leave the results of its hard work for the next agent in the chain to find. This lets them communicate without needing to know anything about how the other one works. It's brilliant. So what happens when you put all of this together? You've got domain isolation, an orchestrator, and a shared state. Well, what you get is a system that can finally breathe. It's not this tangled, overworked, stressed out monolith anymore. And here's exactly why it's so much better. The data extraction is super clean and accurate because that agent has one simple job to focus on. The database updates are precise and correct because that agent isn't being distracted by a bunch of other logic. You've essentially transformed a single point of failure into a system that's scalable, robust, and distributed. Honestly, I think Margaret's final quote just wraps this all up perfectly. She said, "When you stop building monolithic agents and start building modular teams, the whole architecture finally has room to breathe." And that is the absolute key takeaway. It turns out specialization and teamwork, they aren't just for humans. All right, I know that was a lot to take in, so let's do a really quick rapid-fire recap of the big ideas we just covered, just to make sure they all stick. First up, the multi-agent system. This is the whole big picture idea. Instead of one AI trying to do everything, you build a team of independent agents that work together to tackle a much larger problem. Next, domain isolation. This is all about focus. You give each agent only the specific tools it needs for its job. That's what stops it from getting confused and making mistakes. Then there's the orchestrator. Remember, this is your manager, agent. It doesn't do the work itself. It just breaks down the request and delegates the tasks to the right specialist on the team. And finally, the shared state. This is the communication system. It's that shared memory, that digital Dropbox, where one agent leaves its results so the next one can come along and pick them up. So we'll end on this thought. This model for building AI, it's more than just a clever technical fix. It's a really fundamental shift in how we think about designing intelligent systems. It really makes you stop and wonder, if AI truly works better in specialized teams, just like we do, what other massive complex problems are we now ready to solve next?